Hey geometry students, welcome to lesson 4 9.5, and today we are going to be learning a little bit about trigonometry. Trigonometry always deals with right triangles, so you got to have a right angle to use trigonometry, at least with what we're doing here. So trigonometry, we're going to learn the basics about trigonometry, dealing with things called sine, cosine, and tangent, learning some of these basic trigonometric ratios. Very practical stuff. There's 7 more examples in your book. I'm just going to do a couple here, but make sure you check out those extra examples. I may even bring them up down here. I've got them in an electronic version down here. So first of all, let's define what these things are. So this is always going along with, I already said it, I brought up the webcam because I really want to make that point hit home, that we are just dealing with right triangles in the trigonometry that we're doing in this class for geometry. So a couple of lessons dealing with the basics of trigonometry. So for right triangles, this has to be the case. I'm going to use some different colors here. You can if you want. This is not something you have to do in a different color, but this is something that I think would be helpful to do in a different color. So this is not a requirement if you're one of my students, but I think it'll help it stand out a little bit better if you do. I'm going to use 3 different colors here rather than just one. So if sine stuff is going to be in blue, cosine stuff I'll put that in red, and tangent I'll use green. And all these things really stand for, or really are representing, are just fractions in a triangle, just different ratios of a triangle. You may have seen some buttons like this before on a calculator. So let me bring up the calculator here, and this is my scientific calculator. You may have seen these buttons that say sin, cos, and tan. You may have wondered, what the heck are those all about? I've never had to use those before in my life. Now you are going to use them for the first time. For some of you, probably first time in your life. So sin stands for, is the shorthand for sine. So sin of any angle, or any triangle I should say, is always going to be opposite over hypotenuse, and I'll talk about more what we mean with that in a second. So opposite over hypotenuse, sometimes I'll write that op over HYP, OPP over HYP instead. Cosine has the shorthand like that, cos, and that is adjacent over hypotenuse. That's the ratio that we use for cosine. And the ratio that we use for tangent is opposite over adjacent. So at first, this looks a little daunting to try to memorize all this. You are going to have to learn all this. You're all going to have all this memorized. But I got a couple of clever ways I think that'll help you remember what's what. So my first way that I've used in the past that has helped a lot of kids out is that Oscar had a headache, and maybe you had a headache over algebra at one point in your life. So that's what I have students remember, one of the things I'll have students remember. So Oscar, write this all out for me, had a headache over algebra. You'll notice why this works, or why this is a good mnemonic device, is because look at the first letters. It's O and H, that's opposite over hypotenuse. A and H is adjacent over hypotenuse, and then O and A is opposite over adjacent. And one other way that students seem to like, it seems to be about half and half, whatever students prefer, whatever you prefer, use whatever way helps you better. So kind of sounds like a Native American phrase almost to me. SOHCAHTOA. If you can remember that word, SOHCAHTOA, this should help you out quite a bit. I'm going to put that in black. So SOHCAHTOA, what that all stands for is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So these are a couple of ways to help you remember what's what. So you can either use this way, if you like that better, if that helps you out more, or you can use this way. If you're going to use this way, you just have to remember that it's sine, cosine, tangent is the order for these things. If you remember SOHCAHTOA, that's built into the little phrase there, the word there. So let's see how these are utilized. So let's go to some examples and get right into it. So going back to this, I'm going to draw a right triangle though first. We're going to come back to that in just a second. And so please draw a right triangle. It looks, you don't want to use yellow. It looks like mine as best you can. I'm going to make that bottom left angle the right angle. So let's put our little box in the corner there. And then let's write in that this is going to be E, F, and D. So triangle DEF, and EF is 14. FD is 48, and DE is 50. I use the Pythagorean theorem to come up with a triangle that actually does work. So if you plug this into the Pythagorean theorem, or you use the converse of the Pythagorean theorem, this would be this squared plus this squared would actually equal this squared. So this is a legitimate triangle. So let's first of all look at angle D. So you're going to find the sine, cosine, and tangent of the acute angles. It's always going to be the acute angles. You can't find the sine of the right angle. That's just not how trigonometry works. You can find the sine, cosine, and tangent of the acute angles. So for angle D, we could say that the sine of D, we're going to figure out all three of them, sine, cosine, and tangent of D. It's actually quite easy. Remember, all that these things are just fractions. Sine, cosine, and tangent is just a certain ratio. It's just a certain fraction. This fraction that it is based on what you have here. So take a look at sine of D. So we had opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent opposite over adjacent. So here's angle D, and I'll just put a little red dot here. So I'm looking in this corner here. You don't have to draw that dot. This is just to help us see what's what. So sine, I'll keep this, I'll use blue here. You don't have to use a different color, but I'll use blue just to keep it color coded with what I had before. So what is opposite of angle D? Well, if you say 14, you're right. You look across from or opposite from angle D, and that's what you have here. So I'm going to put, first of all, opposite over hypotenuse, and this is going to be 14 is opposite, and the hypotenuse is always across from that right angle, so the hypotenuse is 50 right here. So this is your answer. The sine of D is this fraction. If you can reduce the fraction, you should, and we can. So we can divide both parts by 2, and we get 7 over 25. So that would be my final answer for that one. So we were using red for cosine, so I'll do that in red here. This is adjacent over hypotenuse. And what's adjacent to angle D? Well, the hypotenuse is always across from right angle, so that's still going to be 50, but what's adjacent to it is the one that's right next to it. So it's this one right here. It's the side that, one of the sides that actually makes up angle D. So this would be 48 over 50, which can be reduced to 24 over 25. But again, you don't have to color code these parts. I'm just doing that for the sake of clarity here. And so this last one, yet Oscar had a headache over algebra. So we have opposite over adjacent, or you can remember SOHCAHTOA as well. This is the TOA, the TOA part of that. And so what is opposite? We already figured this stuff out. Opposite was 14, adjacent was 48. So we have 14 over 48, which is the same thing as 7 over 24. So these are your answers. If it just is asking for the sine of a certain angle and you were given both sides, it's just going to be a fraction. So let's also figure it out for the other acute angle in this picture, which would be angle E. So for angle E, what is the sine of E? What is the cosine of E? And what's the tangent of E? What are all these things equal to? So I'll keep that consistent. I'll keep using blue for sine here. So this is still opposite over hypotenuse, but this time I'm talking about this angle right here instead. So I'll erase this other one there. And I'm talking about angle E. What's opposite of angle E? So opposite of angle D was 14, but now 14 is adjacent to, or right next to, that angle right there. So opposite of E is across here. It's the 48 right there. So we should have 48 over in the hypotenuse. That didn't change. That's still 50. So this one would be, my bad there, that should be 24 over 25. You'll notice that the sine of E was the same as the cosine of D, which would make sense because we just kind of flip-flopped the opposite and adjacent parts. So let's finish up this cosine and tangent here. So adjacent over hypotenuse. Adjacent to E is 14. Hypotenuse is 50. So you get 7 over 25. And you'll notice, just like we probably expected, hope you expected, that sine of D would be the same as cosine of E, because we just flip-flopped those adjacent and opposite parts again. And so here, opposite over adjacent. With this, we should expect that these two get flip-flopped because our opposite and adjacent have gotten changed around. So opposite is 48, adjacent is 14, and that's exactly what it looks like. So we have 24 over 7, reciprocal of tangent of D. So let's move on and do just one more example. Before I get into that though, I'll just show you right here. Here's 9.5. So 9.5, you just got a lot more examples than what we're doing here. We're going to use the calculator a little bit on this one, but we've got a lot more examples to show you right here in your book. So look in your book for extra examples if you're struggling with this. We will do some in class though together too, some guided practice type stuff to get you used to it. But very practical applications to trigonometry too. You can see you can measure heights of buildings and trees. Surveyors use trig all the time. Trig is just short for trigonometry. So let's let's draw another right triangle. This one I will draw, whoa, not what I did there. Still doesn't like that spot, I guess. Still not lifting the pen. Occasionally it will do that on me. Okay, there's that, there's that. There's my right angle right there. Okay, not a very pretty box in the corner. That's a little better. Still not perfect, but that's okay. It's pretty good there. Let's put this stuff. This is original material here. I'll put this all in black. This is going to be 35. This will be y, x, and 6. So we're going to try to solve for the variables here. You may have guessed that already would be the case, and if you said or thought that, you are correct. So I'm going to split this up into two separate parts. Man, stop skipping on me. There we go. And so first of all, how can we figure this out? So let's decide what we need to use. So here's the angle. I'm going to circle some parts here. Don't circle this for me. I'm going to erase these things in a second, but this is just to help us see. So just look here, and look here. For us to be able to figure out these things, we have to have two parts that we actually know and just one part that's missing. So we know this angle, we know this side, we're missing this side. Before, you would have said, oh, I'll use the Pythagorean theorem, but you gotta have two of the three parts to use the Pythagorean theorem. We're missing two sides. We have just one side given to us. But if we know one of the angles, we can use trig. We can use trigonometry to figure this out. Very, very useful because of that. And so let's start working this through. I'll get rid of those circles there though, but keep in mind those are the ones we're using. So what would that be? 35 is what compared to this degree measure is what compared to this side? If you said this is opposite, you'd be correct because this angle is opposite of this side. This side is opposite of this angle. So we're using opposite and we're using the hypotenuse. So go back to here. Which one uses opposite and hypotenuse? Which ratio is that? If you say sine, you are correct. That one uses opposite and hypotenuse. So what we need to use here is the sine of, and this time we're given the degree measure. Back here, we didn't know the degree measure, but here we do. So we plug in an actual number here. Sine of 35 degrees equals opposite is 6. Opposite of 35 degrees is right there at 6. And then the hypotenuse is across from the right angle, that's x. And so from here we can solve for x. So I'm going to use, you don't have to use different colors here again, this is just to help us see. I can make this a fraction and put it over 1, and then that allows me to see, I think, a little more clearly that I can just cross multiply this thing to start to work on my answer. So I can have x times the sine of 35. The sine of 35 is just a plain old number, and we'll see in a second what number it actually is, but it's just a decimal that's between 0 and 1. So 6 over x, we've got cross multiplying, we're going to have 6 times 1 on this side, which is just 6. At this point I could divide by the sine of 35. Again, this doesn't have to be in a different color, but it can be if you want. Now I would divide by the sine of 35. It's just a number here and here. That will cancel. That will leave me with x equals 6 over the sine of 35. You may have noticed something here that I just flip-flopped the x and the sine of the 35, and that's an allowed property. So if you see that shortcut, you can actually skip this middle step and you can just write it like that. But if you don't see that shortcut, or if that doesn't make sense to you, do the cross multiplication, work that out like that. So at this point, I'm going to show you what it's approximately equal to. You could go right to a final answer later on, but how do we get this? So sine of 35, some calculators are a little different than others. I think mine, I don't know if it's actually, I'll do it here if I just type in that. Yeah. So this is fine. I don't know what this extra d is there for, but this is the sine of 35 degrees. I think that maybe means sine in degrees. There's actually something else called radians, but this we want to use in degrees. We're not going to talk about radians in this class. So 6 over that, I'm going to use, I'll go with 4 decimals for right now. So 0.5, pretty common, at least in our book especially, it's pretty common to use 4 decimals when giving an approximation for sine, cosine, or tangent. So 0.5736 would be that rounded off. And then I'm going to say your final answer can be to the nearest tenth. The best answer would be to actually take 6 and divide it by, and I'll put in parentheses, sine of 35. I guess I can't do it that way. I thought maybe I could. So 6 divided by, I have to actually type in 35 sine, and then it'll do that and press equal. It'll give me 10.5 rounded to the nearest tenth. 10.46 would be rounded to the nearest hundredth. Let's just keep this number in mind and see what we get if we use this approximation instead. See how close it is to that. So 10.46068 and so on. So if we take 6 and divide it by 0.5736, that wasn't right. If we take 6 and divide it by 0.5736, there we go. So 10.46025, very close to what we had before. If we're rounding off a little bit though, there is some rounding error here, so the better answer was to take 6 and divide it directly by the sine of 35. So from here, we have found x, we have solved for x. I'll box it in. I'm telling you to round to the nearest tenth. If they tell you to round to the nearest hundredth or something else, do that instead. And so this other one, I got a little ahead of myself there, but let's talk first. Don't write this stuff down. This is just to help us see. So I would use these 3. I wouldn't use x as 10.5 because that has some rounding error to it. So I would use what's actually given to you here. Find 2 things that are given, and then the one thing, missing thing that you want to solve for. So 2 given things are this degree measure and this side length. And so this right here is opposite of 6, and it's adjacent to or right next to the y. Which one deals with opposite and adjacent? I started writing a t because it is tangent. So opposite over adjacent, we're going to use tangent as my ratio on this one. So I'm going to get rid of all those circles and just keep those things in mind. So here we go. So tangent of 35 degrees is the appropriate ratio to use for this one. It's 6 over y. And so the same sort of thing. You could flip-flop the y in tangent of 35 if you saw that. If you didn't see that, we would write it out like this first, cross multiply. I'll represent that right there. You can do that right there. and you get tangent of 35 degrees is 6. Divide both sides by the tangent of 35, which again is just a number, so I'm just dividing. It's like y times a decimal number. I'm just dividing by that decimal number, but keeping it as an exact number by using tangent for as long as I can. So this is y equals exactly 6 over tangent of 35, and then we'll approximate that. So the tangent of 35 degrees, let's clear that out there. Some of you may have to type in tangent first and then 35. Some of you type in 35 and then hit tangent after that, like I just did there. It kind of depends on your calculator. So this would be 0.7002 to the nearest 10,000ths place, the nearest 4 decimals. So this would be 6 over 0.7002, which is approximately, if we put this into a calculator, the best answer is to go right from here to here. But if you use this approximation, if you use enough decimals, it gives you a pretty good approximation too. So we'll say here we've got 6 divided by, I'm going to use 35 tangent exactly because that'll give me a little better answer. So it'd be 8.56888, blah blah blah. So round this off, 8.6 approximately to the nearest 10th. So you could check your answer by plugging this back in. You'd have 8.6, 10.5. I'm just going to write down, don't write this down off the side unless you really want to, but write down what I mean by that. So we could check our answer by checking and seeing if 6 squared plus 8.6 squared was approximately equal to the 10.5 squared. If it was, I'll put a question mark there. If this checks, then you can be pretty darn sure you got it right. So if it checks, I'll just say you're probably good to go. So if you had enough time on a quiz or a test to check your answer like that, that would be a very good thing to do to see if it actually works out. If it does work out, you know that that was most likely the right answer. You probably did that right. And so another thing, you could actually solve for this missing angle too. This is what we're going to do in the next lesson, is actually solve. It's called solving for the right triangle, where you find all 6 parts. Here we know 5 parts. This angle would be easy enough to figure out though. It'd be 90 plus this would be 125, so what's missing would be the 55 here. And so you can figure out all 6 parts as long as you have 3 of the parts in a right triangle. As long as you have a right angle and 2 of the other parts given to you, you got what you need. So hopefully you found that helpful. Again, go back to your book, find those 7 examples in your book, take a look at some more of those. Trigonometry can be, until you get the hang of it, can be a little daunting looking at first, but really once you get the ratios down, it comes along pretty easy. So make sure you study those ratios. Remember SOHCAHTOA, or remember Oscar had a headache over algebra, and you should be pretty good to go.